MongoDB, creating a database class. The MongoDB package in Node.js provides a driver for working with a remote MongoDB database. Based in JavaScript, most of the functionality, such as connecting and working with collections, use promises. At the same time, creating a separate class, database, can better help organize the code into separate methods. This would allow for easier testing of individual parts before using the methods with other systems or code. Creating a database class to handle all database-related functionality means accounting for common operations. As part of a class with its own properties, this means defining a constructor method. Working with MongoDB also means two other methods, connect and close, corresponding to connecting to the remote MongoDB server and then closing that connection. The acronym CRUD, create, read, update, delete, is a useful mnemonic for remembering the common operations. As part of a database class, at least 6 methods would be needed along with its constructor. The constructor, the connect, the close, create, read, update, and delete, composing 6 methods plus a constructor. The initial 3 methods, constructor, connect, and close, define the initial structure. And here on this slide is the initial database class with its constructor, a connect method, and a close method. Based on CRUD, create, read, update, and delete, at least 4 additional methods are also needed. So this is all 6 methods, plus constructor. Constructor, connect, close, create, read, update, and delete. The Mongo client object has a method called connect, which is used to connect to the remote MongoDB server. When provided a URL, it connects to the remote server and returns a connection for performing additional actions. Notice this initial connect method. There is the connect method, and then inside const connection is equal to the object MongoDB client and its method usage connect with a URL. The connect method would connect to that URL and then return some type of connection object, which then could be used for additional actions. While creating a variable within the database.connection method seems to make sense, it creates an issue. Other functionality need the same connection. When created, this connection object would be used across other methods. Any values used across other methods within a class need to become a property. So then, adjusting for this, moving into the next slide, we see the purpose of the constructor method is to construct, hence its name. Because connection is needed across methods, it should appear here first. Notice now in this new adjusted code, the constructor method with a this.connection variable equal to null. Notice within the connect method, this.connection now is equal to MongoClient.connect with the URL as a first parameter. The value null used within the constructor as the value of this.connection is a very specific value. Because it will be overwritten by the connect method, this allows for testing for the value in other methods. Other methods then can say, is this null or is this not null? If it is null, then the connect method either hasn't been called or isn't finished yet. And if it is not null, then other operations can continue. Again, because this connection has a specific value, null, this can be tested for in other methods. For example, in order to close the connection, the value connection must be set by MongoClient.connection. Notice now the close method within database. As adjusted, the close method is testing, is this.connection equal to null or not? If this.connection is not equal to null, then it means it has been overwritten by the connect method within database, and thus this.connection.close can be called safely. In close then, connection can be tested. Is it null? If so, the connection cannot be closed. This usage then of testing if the connection exists will be a common theme across future methods within this video. In MongoDB, collection methods also need to know which collection they're operating on when performing actions. This makes collection another property, along with connection. However, a database contains collections. This means database is also needed. And so now we have 3 properties within the database class, connection, database, and collection, all of which are set to the initial specific value of null. This gives a very specific value to test against in other methods to see if the connect method has finished. In database, the use of connection, database, and collection properties allow, as I mentioned, sister methods to use these values. The Mongo client connect method returns a JavaScript promise. This means the keywords async and await can be used within it. Notice the adjusted code here. We have async with now the adjusted connect method. This.connection is equal to await MongoClient.connect. In this case, it will await for the connect method to finish, save the value passed to it as this.connection, use this.connection to select a database, and then use the this.database to select a collection. However, what database and collection are being used? In this new adjusted code, the database.connect method uses DB and collection on this.connection and this.database correspondingly. Where does it get those values? These can simply be parameters to the connect method itself. We can pass in what database to connect to and what collection then to choose. In the new adjusted code, it looks like the following. The constructor, connect, and close methods of the database class now look like this. In the constructor, 3 properties are created: this.connection, this.database, and this.collection, all of which are set to a specific value null. In the new adjusted connect, it has 2 parameters, database and collection. Now within the connect method, this.connection is equal to what is returned from MongoClient.connect. This.database is equal to this.connection.db with the passed in database value. And this.collection is equal to this.database.collection with the passed in collection value. Finally, the updated version of close, as is testing, is this.connection equal to null or not. If it's not equal to null, we can safely close the connection because connect has been called and connection, this.connection, has been overridden at some point in the past. So let's move on to look at all of the different CRUD operations, starting with C. In MongoDB, the insert1 method creates documents in a collection. The initial create method looks roughly like this. Notice it's now testing, is this.collection equal to null or not? If it's not equal to null, then it has been safely overridden as part of the connect method previously, and the insert1 method on the this.collection object can be run. However, the create method within this database class needs to know what to insert. It's got to insert something. This can also be a parameter, like previous usage on the previous slide with the use of database and collection for the connect method. We could pass in document. This is the document to insert within the collection. Notice the revised create method at the bottom of the slide. Create, and then as a parameter, document. Notice the use with insert and now this document value. So if this.collection is not equal to null, you can safely call this.collection.insert1 and then the document. This is very similar, moving progressively across the letters C, R, U, and D to how read would work. However, there's kind of an issue that crops up in this. Insert1 returns a promise. So this means, similar to connect, that the async and await keywords can be used. So to return the created document, or the created result in this case, the result of insert1 can be used. But what if collection is null? So if this happens, a new variable, created document, can be used. In the case of the code at the bottom, created result is the result of that operation. So it can be set to null, similar to how within the class, other values are set to the specific value of null, and then overridden if collection is not itself null. Notice the revised create method at the bottom of the slide. We have the create method with a created result set initially to null. If this.collection is not equal to null, then it can safely be called insert1 with the document. However, if this.collection is equal to null, in which case the connect method has not run yet or is not finished yet, then created result would be equal to null. Otherwise, it would be overwritten with whatever the inserted result was when inserting that document. This is very similar for find1. Find1 also returns a promise, but unlike create, which needed a document, the read method in this case needs a query filter. However, despite this different parameter, the pattern is the same as it was in create. Notice the new revised read method. The read method here has found document instead of the previous variable, but it's also equal to null. But if this.collection is not equal to null, the find1 method can be used on the query and it will be overwritten. Otherwise, the initial null value or the overwritten null value will either be returned as a variable found document within the now adjusted read method for the database class. This will be very similar to the next letter in turn. So create, read, and now update. The Mongo collection method update1 works like find1, but it also changes a document, so it needs two parameters. It needs both a query where how to find the document and an update which properties and which new values should be updated. Notice the new revised update method looks very similar to the previous revised use of read. The update method and the read method look very similar, but update needs that additional parameter. As a reminder, as is put at the bottom of this slide, update1 expects the MongoDB operator set with a $sign when updating fields. And notice now in the updated code for the use of update1, so this.collection.update1 has the query, what document to find, and then has set, and then what properties and what values to update as its fields for that single document. As will perhaps not come as a surprise, moving from create, read, update, and then finally delete, the delete pattern is very similar to the previous patterns used. The MongoDB collection method delete1 also works like find1, but for parameters, it needs only the query, similar to find1. So notice that the pattern for delete in this case, the revised delete method of the database class, looks very, very similar to the find1 pattern. And in fact, the pattern across all of these documents look very, very similar. Notice for this delete method as part of this database class, it uses be passed the query, it will delete one, and then could return the deleted result. The deleted result, like in the previous uses of methods, will either be null if this.collection is equal to null, or will be whatever the deleted result was as returned from the remote MongoDB database. Finally, as a little bit of a bonus, the find usage of MongoDB can also be covered. So the MongoDB collection method find returns a cursor. It's the only one that doesn't return a promise. The find1 returns a promise, update1 returns a promise, delete1 returns a promise, and insert1 returns a promise, but find does not. Find returns something called a cursor. However, this cursor has its own method called toArray, which will convert whatever it found within the cursor to an array and return those values. This itself, however, returns a promise, and this is incredibly useful. So with a read method already existing within database, the use of find, which would find many, means the existing method's name needs to change to read1 for the existing find1, and the use of find in a read many method. At the bottom of this slide is an added read many method. Notice it looks very, very similar to read1, however, it uses the find MongoDB collection method, and then at the end of it has toArray. So this will find the results and take the cursor, use the cursor's method of toArray, and convert it to an array. So the found documents will either be equal to null or an array. as shown here for the read many database method. All of this said, let's now transition over to Visual Studio Code to show the entire database class used together and some example usages to test how this is going to show up. I will also be demonstrating the use of the methods within MongoDB Compass within a particular collection chosen for the use of this example. But let's move over to Visual Studio Code first. So in Visual Studio Code, I have used the split editor to split two different files. On the left right here is an index.js file that is importing a database and has an async function with some functionality that will be used one by one. Over on the right-hand side is all of the code pointed out across this video. For all of the slides, it has the constructor, connect, close, create, read one, read many, as was just covered, update, and delete. Notice the patterns for create right here is very similar to the pattern for read one, which is very similar to the pattern for read many, which is very similar to the pattern for update, which of course is very similar to the pattern create. In each case, however, it's calling a different method on the MongoDB collection. For insert one corresponding to create, find one corresponding to read one, find and then to array for read many, and update one for delete, and of course delete one for delete. So let's test all of this functionality. So before I do anything else, I'm going to point out over here on the left-hand side, I am first creating a new object called DB based on the database class, which I am importing at the top of this file. So I am creating a new object based on this database. And then within this function right here, my lines 5 through 12, right here in the client code, I will be calling various things. Because this is an async function, I am also using the keyword await. In this case, I'm going to await for each method to complete each thing in turn, and then we will see the results of that. First though, before I run any other code, I'm going to move over to MongoDB Compass. In Compass, I will refresh just to point out that there is no data in this collection. So the very first thing I want to test then is if I am able to create data. This corresponds to the constructor, the connect, and the create methods within the class. So moving back to Visual Studio Code, I am creating a new database, which we'll call the constructor. So this right here, my line 3, will be these lines 6 through 10. Then right here, my line 6 on the client will call over here and wait for this to finish, await for this to finish. Right here, my lines 12 through 16. In which case then I want to create. So I am going to uncomment out my line 7, call db create, and pass it in right here an object literal. Over here on the client side in JavaScript, this object literal with a property and its value will be translated into a document with a single field, example field. MongoDB will also take care of generating an underscore ID, which means I could potentially create multiple documents with the property example field and the exact same value, some value, and MongoDB will make sure those are unique. So let's go ahead and save this change, and I will run this file. So when I run this, it will create a new database right here. Then down here, we'll run this, jumping back up the lines 5 through 12. So it's going to connect to what I just showed, Portfolio 2 and Dan Cox. Then it's going to create a document called example field. And then notice with the close that it closed. Okay, so let's verify that worked. I'm going to move over to MongoDB Compass. And I'm going to refresh. And there we go. Notice it generated underscore ID, making this unique, and example field is some value. Fantastic. Okay. So now let's see, moving back over to Visual Studio Code here in just a moment, now that it's put, now that we have created it, can we actually find this? So moving back over to Visual Studio Code, let's comment out this create right here. And then let's change this create to read, corresponding down here to read one right here. So I want read one. And I will comment out this code. Well, if I find the document right here, it will return it right here, or it will return null. So let's go ahead and take this value. And we will put it on the console. So we know now that this previous line 7, we know create works. Now we're testing to see if read one works. So we will reconnect to the remote server. We will attempt to find a document where it has a field whose exact value is some value for the corresponding example field. It will then save this as document right here. And then we should see it on the command line. So let's go ahead and run this code. And there we go, right there. That is what we expected to see. In fact, let's verify that. So the last 4 digits are 37, or last 4 corresponding ID is 37F1. Let's go check in MongoDB Compass. Is that the exact thing we got? So over in Compass, we should be able to see. Make this slightly bigger here. It is 37F1. Okay, so that is correct. That is the correct one we found. So let's move back to Visual Studio Code and see now if we can update that. So over here in Visual Studio Code then, let's skip over read money for the moment and scroll down to update. So what we want to do then is we will take this line out for the moment. What we want to do is uncomment my line 9. When you say, okay, for an existing query right here, find the document whose field has the value, some value for example field. Then update it right here so that its field, example field, is now equal to new. And I will save this right here. So what should happen is it should find some value right here, then it should update it to new. So if this works correctly, what we should see in MongoDB Compass is an adjusted value. Instead of some value, it should read new. So let's go ahead and run this. Okay, so we didn't tell it to show anything on the console. Let's double check in MongoDB Compass if it worked correctly. Okay, currently some value, and let's go ahead and refresh it. We see new. Okay. So update works. So far, we have verified our constructor works because it created the properties we're using. Our create method works. So we were able to insert stuff. We also know that our connect method also works, and our close method also works as well. Okay, so let's move through these in turn. The next one to test would be delete. So let's move back to Visual Studio Code. Okay. Comment out this line. So now we know when I just updated, this will be new and not some value. So let's comment out my line 10. And I will save this. So now what's going to happen is we're going to connect, and then we're going to delete. And so it should look for the query, the document, whose field, example field, is now new and not some value. Okay? Okay, it closed. Let's move back to MongoDB Compass and verify if this worked. So we see it, but if we refresh, we don't see it anymore. Okay, so delete also works. This collection has no data. We deleted it. Okay, let's move back to Visual Studio Code. So finally, come down here and take this out. So as one last test then, we want to test read many. This right here, on this side over here in the database codes, lines 44 through 52. So to do that, we now need to add some documents. So let's create some documents. As I mentioned, MongoDB will make sure things are unique. So let's go ahead and add 3 different documents. So since we now know the create method works, we will create something called example field some value, example field some value, and example field some value, and MongoDB will take care of making sure they are unique. Okay, so let's run this. Okay, now let's verify in MongoDB Compass we inserted those documents into the collection. Hit refresh. There we go. 3 different documents, and MongoDB is taking care to make sure they're unique using the _ID, which we don't really care about at the moment. So 3, fantastic. Okay, so what we want to do then is moving back over to Visual Studio Code, we want to see if we can read many. Can we get an array with those documents out of the collection? Well, it's not terribly complicated. So let's come down here. We will, for the moment, not add any more, and change this from read one to read many. And so what are we looking for? Well, we are looking for all documents whose example field is equal to the value some value, which we currently know is 3 different documents. And we want this result. So we want the found documents. And we will just, for the moment, put this on the console. Okay. So now when we run this, we should find 3 different documents, and it should be an array using this toArray method of cursors. Okay, so let's run this code. And there we go. Opening, closing square brackets showing it is an array and all 3 different documents found from this collection. So read many works as well. So all of these different methods then of this database class all use the different collection methods as part of MongoDB. And it has a constructor, a connect, close, a create, a read one, a read many, an update, and also a delete. As a little bit of bonus, let me show you something extra here. It isn't a whole big stretch to move from delete one to delete many, which is also the case of update one to update many. Let me show you what I mean. I'm going to change this for delete. I've now set this to delete one, but I actually want to delete multiple things. I'm going to change this to delete many. I will save this change over here. Now I will take out my changes I made over here, comment this out for the moment, okay, and come down here, change this from new, which was the previous updated value, to some value, and save this change. So what should happen now is this client over here should connect to the database, and then come down here to this line. It's going to call the delete method, which will call this code right here. But I changed what it calls for collection methods. My line is 68. So instead of delete one, it's going to call delete many. So let's go ahead and run this. Okay, it finished. Well, let's verify that in MongoDB Compass. So we knew previously we created 3 different documents, and we used the read many created function as part of the database class to read these. Well, I just used the delete many method of collections, but we know there's 3 documents, or at least there were. Let's refresh this. And now they're gone. The change from using delete one to delete many is only that, the change of delete one to delete many. Let's move back to Visual Studio Code. Delete many also returns a promise, just like delete one does. Update one and update many work in fact exactly the same. In fact, so does insert one and insert many. Of course, for insert many, you would be passing multiple documents, which is slightly rarer to use. But transitioning from update one to update many and delete one to delete many is not a big deal. They work more or less the same. The only difference is what they act on. Update one acts on one document only, and update many updates multiple documents. The same with delete one and delete many. Delete one only deletes one document. Delete many deletes all of them that match the query. So having these multiple methods here would not be a big deal to add to the database. In fact, to optimize this, it would probably make more sense to actually use update many and delete many corresponding to update and delete, because we would be looking for very specific documents within a collection, and we would not necessarily need to worry about deleting one or deleting many. We would just delete many and update many each time. So implementing these additional collection methods is not necessarily a big deal, especially for update one to update many and delete one to delete many. Find one is, or insert one is slightly different, but again, it's slightly rare to insert multiple things at the same time. The only major difference would be, to just change this for a second, that insert many expects an array right here. Docs array just expects an array of documents instead of a single document. Not a big deal to adjust that code. So this has been a review starting from talking about how to use the different MongoDB collection methods, moving into creating a database class, and pointing out how the patterns of using them are very common across all the collection methods. Notice my create looks pretty similar to my read one, which looks pretty similar to my read many and pretty similar to my update delete. What is different across all of these is, of course, which individual method I'm calling. Again, not that terribly different and not actually complex at all. Just understanding each corresponding action. Create matches to insert one in this case, read one, find one, update many that I just changed it to, and delete to delete many. Mapping all of these from one thing to another to another. And correspondingly in the client code over my left-hand side of Visual Studio Code, I can write a simple function just to see if each thing works. Move over to MongoDB Compass and see, oh, did I create it? Okay. Can I read it? Okay. Can I update it? Okay. Can I delete it? Okay. And once I know all of these things different, all of these class methods work of the database class, I could then add on additional things, work with other systems such as server code from there.